Alright, today we're going to be looking at section 3.5. This is the 5-number summary and box plots. The main objectives here are going to be to compute the 5-number summary and to draw and interpret box plots. So this is all good reading, kind of tells you about the background and what it's used for. So then it begins to explain how to find the 5-number summary. So it's telling you the median is the 50th percentile, divides it into 50%. Then it goes into some other measures of dispersion, just kind of reminding you of range, standard deviation, and variance. Those are all affected by outliers or extreme values. The interquartile range is not. The quartiles are not affected by extreme values. And so the quartiles in and of themselves don't give you much data. So the 5-number summary just adds the minimum and maximum to the quartiles to show you the smallest value and the largest value. So here's some data that kind of go through sorting it, explaining how to find Q1, Q2, and Q3, and then you add the minimum and maximum and you get your 5-number summary. So we have several ways that we can display this data. We can use it with technology, which at the end of the section I'll point that out to you. But here is the steps. So you're going to determine lower and upper fences, to determine if you have outliers. You'll go through the process where you find the minimum, maximum, all the quartiles. Each of the quartiles are going to be enclosed with a vertical line that's going to make a box. We're going to label the lower and upper fences, draw a line from Q1 to the smallest data, and the same thing from Q3 to the largest, and those will be called whiskers. And you go through and you can make a star or asterisk for an outlier that goes beyond the fence. So here's some of that spelled out in an example. They took the data, they made Q1, Q2, Q3. Those are like vertical lines on a number line at the approximate location of what that value is. So like Q3 is 37.24, and so that line would represent about 37.24 right above it. So this would be your box, okay? And then if we continue, we add the lines. These are what they call whiskers. Sometimes they draw little endpoints on them, but this will be a box plot with whiskers that they're referring to, and then they have like a little bracket to denote the fences, and if there was a value that was bigger than one of the fences, so the fence looks like it stops at about 54-ish, 54.1 is what they got. And then if there's something bigger than that, it would be an asterisk. That's going to be a outlier. So just some other representations of data with here's the data, here's the box plot. So you can see how the box plots are drawn when you have skewed right, skewed left data. So the whiskers are very uneven. In the middle is symmetric, so they're kind of even, about the same length on both sides. And then here, the left side is uneven compared to the right. You can use a box plot to compare two distributions, which is awesome. You can put them on the same thing and kind of see some information about the spread. And then this is also very great. It tells you step by step how to do this information in the computer. So you can do it with the calculator. This is the one I'm most familiar with. It gives you the steps to do it with Excel. So these I haven't used very much, but this might be something you want to use. And also in our MyMathLab or MyStatLab, it has the StatCrunch program already in there. So this might be something you want to go through and practice trying to make box plots with this. Most of the time I'll probably use the 83 or 84. I might use the StatCrunch. We can even try it in Excel, but try to get familiar with all of them. Knowing different ones will also help you out. So anyway, that's about the end of this section, so we'll jump over to MyMathLab and begin working some examples.